Okay. Hey, Mr. Keller, doing test corrections for exams 7, and so we start with number 4. An arrow with mass of m and speed 100 v strikes a foam ballistic pendulum with mass of 10 m. So you're trying to find the speed of the pendulum as it begins rising. So you would use, you would do 100 mv equals 80 mv plus 10 mvp, and I use vp, which is the velocity of the pendulum, because you don't know what it is. And so then once you subtract 80 mv from this side to this side, you get 20 mv equals 10 mvp, and you divide by 10 to get 10 m to get the v alone, so you get vp, and it's 2. The answer is 2, and so the answer is E, none of the above. Okay, now we move on to number 7. So number 7 is: an empty train rolls freely along level train tracks when a stuntman falls onto the car from a ledge above. Taking the car and the stuntman to be the system just before he lands, the momentum of the system is what, and the kinetic energy of the system is what? And so the answer should be remains constant, and it decreases, and it remains constant for the momentum, because the momentum isn't changing, like nothing is going the opposite way to change the momentum. Whereas for kinetic energy is lost, or it's not conserved. Energy is never lost, but kinetic energy is not conserved during an inelastic collision. Okay, so now move on to number 9. And number 9, I was a little bit confused about the third picture, because it doesn't show them together when they first go off, so I was a little confused during the test, but I'm gonna say that they're all 4, because you have to add which ones. Like, you have to take this point and then you have to add this to it, and you have to say if that makes this. And so I said all 4 make that, but I was just confused on this one because they're not they don't start from the same point. Okay, so now we move on to number 10. Number 10 should be B, because as the puck strikes it, and first I said 135 because I thought because one of the pucks was going to the right, the other one would have to go to the left, but that isn't the case. If you add them up, if it's just going straight up, it would work. So it should be B, 90 degrees. Now we move on to 11B, which is right here. So you're trying to find out how much kinetic energy is lost in the collision. So you're doing 1/2 mv squared minus 1/2 mv final equals delta k. And after you do all this math, you get delta k equals 2,381.05 mv squared. So that's the answer. Now you move on to 11C, which is how high will the ballistic pendulum rise. And so you're just doing kinetic equals potential. And so then you can cancel out the m's because it's the same, and you end up, after you get all this mass, you get the pendulum will rise to 0.28322 meters. And then we move on to 12B. 12B is conservation of momentum. So you're doing mv plus mb equals the initial. And so yeah, and since you know the initial from one before, yeah, you end up doing, hang on a second. Yeah, so after you do this math, you get that the truck is traveling 3.3 meters per second to the right. And then moving on to 12D, the collision was not elastic, and that's because you have to do it's conservation of momentum, so you have to do 1/2 mv squared plus 1/2 mv squared of the initial, and then also 1/2 mv squared plus 1/2 mv squared of the final. So after you do this, you get 6.724 for the initial, and then the second one is actually 6.472. So it's not the same. That means it's not elastic. Okay, thanks. No.